All right, everybody, we're back on 5.2. Just a couple more questions that I wanted to go over before we leave this part of the course. We looked at fairly simple integrals last lesson in part 1. Now we're going to make them slightly more complex. So I'm going to start with this one here, which is the integral of x squared plus x plus 1 over x squared plus 1. So right away, you might try u substitution in the denominator, and you would see that you're going to end up with a 2x dx, which doesn't help us because the numerator is a second degree polynomial. And the same thing is going to happen if you sub out the top part here, okay? It's going to give you 2x plus 1. It doesn't help you out. So what do? Well, you have a couple choices here. Erase all that. First choice is going to require you to remember your math 12, which is long division of polynomials. Okay? And so we have to do long division because the bottom is non-linear. So you can't use synthetic, i.e. it's a degree 2. If it was x plus 1, you could do synthetic division and it would work. But it's non-linear, it's a quadratic, so we have to do long division. This is a fairly simple one. So what you do is you ask yourself, what do I multiply x squared plus 1 by to get x squared? Well, it would be 1. And you remember you multiply the 1 by the x squared plus 1. Trick here is when you multiply by this one, put it under the other one. There is no x term in there, so just leave that spot blank. You subtract, the x squareds go away. X minus nothing is x. 1 minus 1 is 0. So this is my remainder because x squared will not go into x. All right, so that's my remainder. This up here is called the quotient, if you remember, called q. And this thing, what you're dividing by, is called the divisor. Sorry. So then we rewrite it as the integral of q plus r over d. So we go, okay, what's q? It's 1 plus, what's the remainder? X over divisor, which was x squared. These are the same thing, okay? If you made a common denominator here and multiplied it out, you would get that back. I guess I should have a dx here. Well, you have an addition sign, so we can break them up. So it's 1 dx plus the integral of x over x squared plus 1 dx. Hopefully, that integral of 1 would just be x. Second bit here, we're going to have to do a u substitution. In this case, it's pretty straightforward because the bottom is degree 2, the top is degree 1. So when I take the derivative of the bottom, I get 2x dx. I divide off the 2, and I get that. So the second integral becomes 1 over u du over 2. The 1/2 can come out. X stays the same. So it's this. And that is the logical. Hopefully you remember. And what was u? X squared plus 1. There you go. Now, there is another way to do this. If you look at this integral, and you look at the numerator, it's got an x squared, it's got a 1. So does the denominator. So I can rewrite this without doing long division. I can simply just write it as, let's do this in a different color. I can move this 1 over and get x squared plus 1 plus x over x squared plus 1. Okay, I didn't do anything fancy. I just moved the 1 and the x. The reason I did that is this is the same as this. x squared plus 1 over x squared plus 1 plus x over x squared. Okay, hopefully that should make sense. These have a common denominator, so I can just add the tops together, the numerators, and you get right back to there. X squared plus 1 over x squared plus 1 is 1. Plus the second bit, which doesn't change. But the cool thing is I have just recreated that without doing long division. Okay, and then the rest of it would be the same to get this answer here. So when you get something that doesn't look like you can do U substitution, you're thinking you might have to do long division, look to see if you can rearrange the numerator or the denominator to see if you can line up so that and split it into two fractions and they simplify nicely. Okay? All right. Number 7. So integral of 2x over x